Welcome to the second part of Administer Intersite connectivity. Now in this part of the session, we're going to continue learning from creating a VNet peering. However, we stopped at talking about hub and spoke and looking at transitive traffic. In this part of the session, we'll look at how we create that transitive traffic by using user-defined routes. Now before we go into user-defined routes, let's understand what our system-defined routes are and why would we need a user-defined routes. So let's have a look at that. Now, system-defined routes are by default created by Azure for you. These are automatically maintaining a routing table in the backend for the resources you create. As and when you create a resource, it creates an entry for that resource in terms of all the connectivity that it has to the resource. For example, if you have a virtual machine in a virtual network, in a subnet, then it will start creating entries for that virtual machine on how that virtual machine can connect to resources that might live in the same subnet or other subnets within the same virtual network. If you have traffic going from that virtual machine to the internet, how that traffic can flow from that virtual machine and what path it can take to reach out to other resources. Now, as you add further resources, things like pairing that virtual network to another virtual network, it will simply keep on adding other paths to it. And this is something that we refer as system-defined route, which is simply maintained and managed by Azure. Now let's have a quick look at an existing system-defined route that we have for one of the virtual machines that we have in our hub VNet. All right, as we're back in the portal, we can see we have our hub paired to the VNet A and VNet B already. So we have the hub and spokes connected. Now, to begin with these details, let's go into the resources that I have working within that environment. Now, to start with, let's have a look at VNet A and go into the resources that are connected to it. So if I check my connected device, I have a resource called front-end server that's connected to my VNet A. So let's go find the server. So I have a server called front-end server, and this is where we have the front-end server. Now, just checking the settings in my network. So I'm connected to VNet A, and it's placed in the subnet. Now, what I want to do is go into the network card settings on this particular resource. And while I am in the network interface card for VNet A, all I'm going to do is scroll down to the bottom of the blade and look at effective routes. Now in this part, I should see the system loading up for me the system-defined routes that are available for this network interface card or this virtual machine to take. Now currently I can see there are only a couple of them or 3 of them available for me to use. Now this is interesting to monitor because we've already created a resource that's part of this virtual network. So traffic within this virtual network, it's already got a route for that. However, we also created a pairing from this VNet to our hub, and that's the network range for the hub. So it's already got a route available for that. It also has a default route available for now currently for internet, which currently stands as that. Again, we can look into changing some of those details, but for now, we'll leave it as it is. Now there are some other entries, but they're not configured, so there's nothing else currently defined. Now as we look at the details on the top of the screen, this is currently the routing table that this current resource is associated with, and that's the path it is taking. Now let's make some changes to it. Before we make some changes to it, what we are going to look into doing at this point is introduce a user-defined route. We want the traffic going from a resource that's my front-end server 1 to front-end server 2, which sits in VNet B. However, we want this traffic to bounce onto the hub and then reach the VNet B. So we are looking at transitive traffic, which I mentioned isn't by default enabled as you do VNet pairing between multiple virtual networks. However, we enable that feature to allow forwarded traffic. But for it to happen, 2 things that we require as part of that. 1, we would need a virtual network appliance placed in the hub that will forward this traffic through for us. 2nd, we need to define a user-defined route, a route that we are adding to this routing table so it can pick up that traffic going in that direction so it can reach the destination. So let's have a look at how we define a user-defined route in the portal. Now, on the portal, all I'm going to do is look at route tables. And let's go define a route table. Now, currently I don't have a route table, so let's go ahead and create. And going through the basic tabs for the route table. Again, not too many details to configure, but the basic details, things like subscription, resource groups, your region. Let's bring this back into UK South, as all the rest of my resources are in that region. And again, that's not necessarily a constraint, but for now, let's bring them back in here. And what are we calling this route? Let's call this UDR for hub and spoke. So that's the, if I can type in hub and spoke. All right, let's create this. Now, by default, it's got settings to propagate the gateway settings route. So if you are using a gateway, it's looking to propagate those connections. For now, we're not using a gateway, so we'll leave the setting out for now and we'll move on. And that's all we need to define, and we'll hit create and review. Right, this resource is now ready. Let's go and have a look at some of the details inside of this route. Now, as I look at my route, apologies, it's jumped back out into the main portal. Let's go back into the resource that we've just created. So we are looking at the route that we've just created. There we go. So let's jump onto that. So we're looking at UDR, hub and spoke, and that's the route we are looking at. Now, currently, there's nothing configured in it. It's just an empty table that we are looking at. Now, there are two key areas that we need to configure as part of the setting. One of them would be to define a route, that how this traffic is flowing through. And the second part that we need to do is assign a subnet that we're trying to connect to. The subnet that we're connecting from. So we're defining, hey, from this subnet, take this traffic to that destination. So this is what we're defining for this particular resource type. So let's start doing some of that. All right, so we've just about created a routing table. Now, before we go into creating the route and explaining on what we are trying to achieve here, let's recap onto how we are doing this. And for this, let's go back into one of the previous slides we covered in the previous part, just to understand what we're trying to achieve as part of the setup. Now, in my current environment, in the demo setup that we are working on, we are looking at creating a connection between hub and spoke, which we've established by doing VNet peering. However, in this part of the demo, what we're trying to do is get the traffic to move from our hub between the spokes and moving between, passing through the hub. So I have a server called front end 1, or for front end server 1. I'll call it as short FES1, but it's front end server 1. And I have a server called front end server 2. So these are two resources that I've got currently running in my setup. Now in my hub, I've got another resource called back end server. So this is what we have in the backend. So it's got back end server running in here. And what our connection should look like, our traffic from the front end server needs to reach the front end server. However, based on the way that we've done the peering under hub and spoke, this traffic will flow between the VNet A and land onto hub. And from hub, it will look into going to a version network appliance that we have, and then bounce this traffic back for us using the connection it has from a hub to VNet B. And this is the forwarded traffic that we're trying to achieve. Like I said before, we need two things: virtual network appliance for this, and we need UDR for this to work. So we're just about creating this particular connection. For now, we are simply going into the routing table to define these details. So let's jump back onto the portal and have a look at this. Now back into the routing table. I've named it UDR hub and spoke. By all means, call it whatever, as long as it makes sense to you on what you're doing. Now, first part of this is we are going to create a route. For me to create the route, we are going to start creating this connection. The route name that we're doing is, let's call it my front end server 1 connecting to front end server 2. Now, hoping that name makes sense. FES12, FES2. So me connecting two front servers together. Hopefully this will be bouncing off my hub where I have a backend server. Now, we will use IP addresses to achieve some of this. So let's choose IP address as the destination type, how we're reaching the destination. Now, I need a destination IP address. So in this case, I need the IP address of my front end server 2. For this, I am going to jump back onto my portal, another tab of my portal, and simply go and find one of my virtual machines that's called the front end server 2, and pick up the IP settings from that resource type. Now, currently, that's the IP setting that I have for that resource. So I'll pick that up and bring it in. In fact, let's change that to a private IP address. All right, let's take this IP address from here, and we're going to try placing this IP address. Now, we just need the IP address for the network we're going into with the details for it. Just be aware if you're pasting them in, make sure there's no empty gaps. Now we have the destination IP address range. So the range is the entire network that we're working on. That's the network that we want the traffic to reach, where my front end server 2 lives. And we are going to define what my next hop is going to be. This is the next hop, typically in networking language, is the next jump that traffic is taking to the next network. So the next network that is jumping on is my hub. However, within the hub, I am using a network virtual appliance. So we'll click on a virtual appliance that we are jumping on, and the next hop address should be what? So we are now defining the destination where it needs to reach, and we're defining how it goes there by adding the details of my backend server, which is sitting in the hub at the moment. Now, for that, let's jump back into the other tab and go into my virtual machines one more time and pick up details from my backend server and find out the IP address for my backend server. Let's jump back into my settings and provide it with that detail here. Now, that's all I need to do to configure. So a name, destination is going to be using IP addresses. That's a network range of the destination resource. We are using a virtual appliance in the middle to bounce this traffic, and that's the address for the traffic that we are bouncing off. So that's currently what we are adding into our route, and that's all I've done. Now, so far, we haven't gone into defining who's using this route or what part of my setting is using this route. And this is where we have to go into the next tab on our blade under the route tables. And this is where we define or allocate a subnet that's going to be able to use this route. So let's go and associate the subnet that we have in our virtual network A for the resource that we're working on. So let's go define virtual network A, and that's where my front end server sits under that subnet. So we'll choose that. Now, defining that you can use this route, which is to jump onto the next hop, which is the virtual network appliance, and then bounce onto the network that we want to reach to, where our front end server 2 lives at the moment. And this is us creating that route. Now, this seems to have completed the connection for me. What we are going to do is jump back into my backend, go into my front end server 1. Let's try that virtual machine one more time. And last time we were looking at a system defined route within this. This time, if I go into my front end server 1 and go into the networking settings for this resource type and click onto the network interface card, and one more time scrolling down to the bottom of this to look at my effective routes that it has. And this time what we can see slightly different as to before already is currently it's using something called UDR hub and spoke. Now, I'm hoping you remember what that is. Now, we just created a user-defined route. Now it's suggesting, hey, this table is associated to this particular routing table that you are working with. So you are using a routing table that you have created, which is a user-defined route. However, if I look into the details of some of the settings of my route, I can see currently there are some default routes still there. So the routes that we had for me to reach the data within my virtual network, to reach the VNet paired network, still exist. And if I scroll down to the bottom of this screen, I can see I have a user-defined route that it's picking up from that hub and spoke UDR that we created, and it's suggesting, hey, you have an active connection that reaches you to that destination that you're trying to get to by bouncing off this particular resource that you have, which is a virtual appliance in your setup. So this is where it's telling me there's a route available for this traffic to take and reach that destination. Now, this shows me that there's a route available. We'll test the connectivity of how things work and how we test some of these things out in the next module, looking at Network Watcher. For now, what we are going to do is simply understand what effects does this have for me in this environment. Now, if I'm assigning a user-defined route to an existing resource, which already has a system-defined route, one thing that's important to understand that it doesn't completely replaces the existing system-defined route. It's simply aiding to it. So if there is a scenario where I currently have added a user-defined route, when the system-defined route doesn't have any path to reach that destination, it can see there's a user-defined route that it can take to get to the destination. It will carry on using the system-defined routes for other resources or other paths that it needs to reach the destination. In the scenario where it has an entry for a destination in a system-defined route and a user-defined route, in that case, this user-defined route will take precedence. So it will be more effective, or it will be effective in case, or it will override the system-defined route that's already in place in your system environment. So again, it's important to understand how they work hand in hand. However, if there is a route that's replicated in both, then user-defined route will be the one that will be effective in that environment. Right, now let's stop with talking about routes at this point, and let's jump back onto the slides to have a look at another topic that we are going to cover again as part of security and connectivity. Right, the next topic that we are looking at is slightly different to the things that we've been covering as part of routes and talking about configuring user-defined routes and system-defined routes. In this case, we're looking at a service called Service Endpoints. Now, Service Endpoint is a very, very good way of connecting to your resources and trying to ensure that your connectivity to that resource is kept secure. Now, let's have a quick look at understanding what Service Endpoint is and how it provides you that security. Looking at the screen, if you look at the current setup, let me break this down for you. In this environment, I have a resource called storage accounts. Now, we cover storage accounts at a later point in one of the modules. For now, we have a storage account connected or created in this setup. I also have a virtual machine that sits in this environment. This virtual machine has its private IP address and belongs to a subnet, which belongs to a virtual network in this setup. Now, what we're trying to look at in this connectivity is typically when you're working with a storage account in Azure environment, these storage accounts will typically have what we refer as endpoints. Now, a lot of the time, these endpoints are public links that you can use to reach the destination on the cloud services. In this case, the endpoint can be used to reach the storage account in typical scenarios. So anyone trying to type this endpoint will typically be able to go through internet and reach your resource. Now, I don't want my service to be available to everybody over the internet, and I want to keep it secure, so only certain resources in my setup in Azure environment are able to see them and connect to them. Now, I can utilize a feature called Service Endpoints to allow me to create this. Now, for me to achieve this, we simply need to ensure that we enable service endpoints for every subnet that we have in an environment. Now, if you are creating multiple virtual networks and you're creating VNet peering, bear in mind this service must be enabled per subnet to allow connectivity. Now, if I have multiple subnets in a VNet and I enable this for one subnet, resources that sit within other subnets in the same VNet or virtual network won't be able to utilize this service. Apart from that, what it also does, it can allow me to block connectivity that comes out from any other network in this environment. So in this particular scenario, what I can do is I can choose, hey, virtual network, let's assume this is called VNet 1. So, hey, virtual network 1, we want the subnet that we have in here to be able to utilize the service endpoint and reach the storage account. In this case, the traffic is not going to be leaving the Microsoft Backbone network. However, the traffic might still be pointed at the public endpoint or the endpoints that we have for this service, but this traffic does not leave the Microsoft Backbone setup. Keeping it secure, ensuring that it is not vulnerable over the internet for users to connect to it, or the service is not exposed over the internet. Now, this particular service doesn't come at an additional cost. However, accessing your resources, such as storage and other services, using a service endpoint might incur some other costs. So please bear that in mind. Particularly, this service gives you options for 11 different, or service endpoints give you options for 11 different services that you can plug onto in your environment. They are typically opened for an entire service, and you cannot be very specific about what service you're trying to connect to. In our scenario, we are looking at Microsoft Storage, and in this case, we'll simply open that for Microsoft Storage. Now let's have a quick look at this in the portal. Now I'm back onto my portal. Now let's jump onto the virtual networks, and what we're going to do is open any one of the virtual networks that we've created. Let's go into VNet A and work with this, and we are going to start looking at creating service endpoints. Like I mentioned before, we can go into the blade for the virtual network and look for service endpoint. Now, if I click on service endpoint, currently I don't have any created. However, if I start creating one, it will suggest what service are you creating a service endpoint for, and you can go and choose. Like I mentioned, there are 11 services that are available for me to pick and choose from. However, I cannot be specific if if I have more than one, which one am I choosing? I can just say open a pathway for, in this case, Microsoft Storage. Then it suggests currently none of them created. For which subnet are you creating? I only have one subnet in this, so I can choose open this service for that subnet, and I can simply hit add. Now this will simply go and assign a service endpoint for this particular virtual network. So the resources that I have within this virtual network, so I have a virtual machine connected called front end server 1. The front end server 1, I can log into it and connect to my storage account. However, to complete this configuration, I might need to go into my storage account to do further configuration, which we'll discuss a little bit more when we look at the storage in one of the next modules. For now, we have a service endpoint created. This can help me secure my connection to the storage or many of the services that we have listed on the screen in the past, and have a secure connection directly rather than sending this traffic over to the internet and bouncing it back onto my service. Now, once we understand service endpoint, we also have another service that we can compare this to, and this is referred as private link. Now, private link works slightly similar to service endpoint in a sense that we are trying to block direct traffic coming directly from the internet. However, this service works slightly different. Now let's have a quick understanding on how this looks like and what we have on the screen. Now in this case, instead of using storage accounts, we have an example of SQL databases. Again, we could pick either one of these examples. It's not a big issue. Any Microsoft service that you've got running in your environment. The whole idea is we don't want direct connectivity from over the internet. We don't want anyone using a direct endpoint and reach my resource. I want to keep this connection private. Now, while I'm trying to do this, using private links, what I can do is I can start establishing a connection for the resource. As and when I go into my settings to create a private link, one of the first things that it starts doing is that it will start creating me a resource within the same virtual network where my resource exists. For example, the VM1 that we're trying to connect to the SQL database will start creating me a network interface card linked to this SQL server in the same network where my virtual machine lives. In doing so, let's assume my network range for this was 10.0.0.0/16, and the subnet that this resource sits under is, let's take it from here, let's say 10.0.0.4, or let's take the range out first, so 0/24, and the virtual machine that we have working in here would typically be 10.0.0.4, and that's my resource that we are working with. Then in that scenario, what it will look into doing is dropping this network interface card into this subnet for me, giving the network interface card an address that matches the same range of where my resource exists. So picking up the next available IP address, 10.5. Now in doing so, what I'm doing is I'm bringing the connection private to that resource type. In service endpoints, where we covered earlier on, where I can open a connection between the resource, the traffic leaves the virtual network and travels on Microsoft Backbone network and reaches my resource or my service. In this scenario, we're bringing that network connectivity within the same virtual network, so traffic does not even have to now leave the virtual network environment and travel outside of that. It is within the virtual network network that I'm connecting to my resource. And also, I can open my private link to a particular resource type, such as choosing a service. So I can define, hey, open this for Microsoft SQL. Along with that, I can be more specific. If I have more than one service running in the backend, I can choose what server I want this to be open to. And even further, I can choose which SQL version I've got or which SQL database I want to pick from there. So I'm not limited to the entire service. In this case, I can be more specific, and I have a long list of options available within my private links as compared to service endpoints, which is only available for 11 different services. This is more specific to a resource type, so I can pick and say open it for just that database and not the others. So not opening to entire Microsoft.SQL, but to a particular server that I have in my environment. And again, this is not free of cost. This comes at an additional cost as a resource. Again, as I mentioned before, that it might require you to configure some more details into your resource that you're configuring. So again, something that we can look at more in detail when we talk about resources like storage accounts. So we can have a look at how you change your network configuration so the traffic can be managed in this manner, either using a service endpoint or a private link to reach your end destination. Now this brings us to the end of the module. As we conclude this module on administering Intersite connectivity, let's recap on the key points we've covered. We started with configuring VNet peering, where we learned about the uses of VNet peering, gateway transit, and connectivity needs. We also explored how to create VNet peering and determined service chaining uses. Next, we moved on to configuring network routing and endpoints. This section guided us through reviewing system routes, identifying user-defined routes, and demonstrating custom routing tables. We also discussed the uses of service endpoint and private links to enhance the network security and efficiency. Hope you have a better understanding on how to administer Intersite connectivity effectively. Remember to utilize the resources and the knowledge check questions provided on Microsoft Learn using aka.ms/learn to reinforce your learning. Thank you for your participation, and we look forward to seeing you in the next session.